Okay, and in my notes here I said, well, if adding at the end makes it go up 4, then subtracting at the end will make it go down 2. So start down 2, start right there, and then the graph will look the same, up 1 and over 1. I'm not changing the shape of the graph, I'm just moving it all down 2 points. So that is what that would look like. Okay, when we dealt with up and down, I guess next we will deal with left and right. So let's look at that. And it's a little counterintuitive when we do this, so be sure you're paying close attention. Okay, so if I have y equals the absolute value of x minus 3, beautiful. Well, that's going to move it right 3. And I'm going to graph this real quick, and you'll be like, wait a minute, but we'll get to that in a second. So hold your horses for 1 second. Let me graph this out first. So if I take that graph and I move it right 3, I start at the origin, because I started with the absolute value of x, and I'm moving it right 3. There we go. Okay, and then from there, up 1 and over 1, draw the v from there. Like I said, I like to start with the base, put it in the right space, and then move the graph over. Okay? Now, it's minus 3. You might think instinctively to go to negative 3 on the x-axis, but that won't work, and just try real quick. What value is here for x? Well, the value is 3, and if I put 3 into this equation for x, 3 minus 3 will give me a y-coordinate of 0. So, because it kind of cancels out that I need a positive 3, minus 3 to give me that 0 I need for y. Okay, so I guess if anything else I can just argue, well, it works. If I put in the value of 3 for x, I get 0 for y. When I put in 3, 3 minus 3 is 0, and that gives me y. So when you subtract right at the x, it moves it right 3. Okay, I'm going to have you try one, and you might be able to guess what you'll need to do here. So go ahead and try it. That y equals the absolute value of x